All right, Algebra 2 kids, this is the second video, and it's just going to be a combination of just some finishing touches. You have a lot of practice to do in regards to solving systems of equations, but if you can get through those documents I posted in Google Classroom, you should be more than ready for your test come next Wednesday. You will have Monday to work on this. You will have Wednesday to work on this. And I highly encourage you, and I want to remind you that you are going through a 9 weeks competition with the rest of the class periods. So utilize working in groups, asking me questions via Google Classroom or emailing me, and just doing the little things that will go a long way. I highly encourage you to go over these videos that I'm posting a couple times just so you kind of get the idea. Really quickly, I did not discuss this yet last class on Friday, but how do you classify systems? This is a very broad question, but I just wanted to go over it really quickly. How do we classify systems? Classification of systems is divided into 3 different parts. 2 of them go along the same category, and there are 2 little parts of the category. But basically, a system is either consistent or it is inconsistent. Now, remember, we had discussed that there are 3 possible ways to get a solution to a system of equations. It is either by one solution, which is where 2 lines intersect, no solutions where the lines are parallel, or infinite solutions where those lines are the same. They're the exact same line. Well, classifying these systems kind of tells you what the solutions are. If a system is consistent, there are 2 options. It is either independent or it is dependent. And then within independent and dependent, it tells you the solutions you can have. So if it's independent, then what do you think independent means? What do you think dependent means? Okay. Dependent tells you that the solution depends on something else. So in other words, dependent is your one solution equation. While your independent is your infinite solutions. Think of, if it's one solution, then that depends on where the 2 lines intersect. So if your 2 lines intersect, that intersection, that solution depends on where the 2 lines intersect. Well, independent just says that it really doesn't matter, which solution you pick. Okay, this is an example of dependent. Okay, this is an example of dependent. While independent says if they're the exact same line, so this is a line and then within there's another line, the solution is independent. It does not matter what the solution is. Okay. Now, inconsistent should automatically trigger that this is no solution. This is telling you that there are no solutions to the system of equations. Thus, we're dealing with lines that are parallel. And that was a poor drawing. Pardon me. Let me move this down a little bit. That was a poor drawing, but that is to resemble two parallel lines. When you have parallel lines, that means there's no solution, which means it's inconsistent. If you have a solution, then you need to figure out if it is one solution or infinite solutions, and within that, if it's one solution, it's dependent because it depends on the intersection. If it's independent, that means it doesn't matter what the solution can be, it doesn't depend on anything. That means it's infinite solutions. Okay, so these are different ways to classify systems, and that gives you what kinds of solutions there are, whether it's no solution, infinite solutions, or one solution. Okay, so that is a really quick overview on how to classify systems, and you will be asked on the test to do that, and there's a lot of practice with that on the test review as well as the practice review. So you'll get a lot of practice with that. And just to reiterate something, I will put up the steps to putting in matrices into Google Classroom, but I'll also put it in this video. So if you recall, let's scoot this up again. If you recall, to set up matrices on the calculator, okay, you do second plus x to the negative 1, and that takes you to that will take you to the matrix window. Okay. Within the matrix window, you'll have like a list. It'll be like A through, and I'm sure it goes to Z. I haven't looked that far, but it just gives you a list of matrices at the start. I believe the little subcategories are list, and then there's math, and then there is edit. Okay, whenever you are checking your systems of equations and trying to double check to make sure your solution is correct, you always want to start with edit. Edit will give the same list of matrix letters, A to Z. You want to edit these. Whenever you get into edit part, you will usually select an A is 1, B is 2, and it goes on from there. You always want to start with A. So when you click A, so when you push 1, so when you press 1, it will take you to another window, and it will say, what is your matrix? So it'll have the little brackets, and then it will say, well, currently it's a 1 by 1. What do you want it to be? And depending on your system of equations, it could be 2 by 2. It could be, let me scoot this over. So it could be 2 by 2. It could be 3 by 3, and it goes on from there. Okay, you have to fill that in. So you'd put 3 by 3, and it would expand to fit, so you can input a 3 by 3. And remember, you're putting in coefficients. So you are putting in, coefficients into the matrix. Okay, so you'll put the coefficients in depending on what system you're solving. Okay, once you do that, then your A matrix is done. A is done. Then you need to do your B. You need to do the same thing for the B matrix. So you repeat. So repeat. Let me move this up. Repeat for B. So you repeat for B. Now B is the answers to the solution, and that is going to be either a 2 by 1 or a 3 by 1, depending on the size of your system. Okay, so you'll put 3 by 1 into the window. So you'll repeat these steps, and you'll put a 3 by 1, and you'll input those You'll input those numbers. Then to solve the actual matrix, okay, remember let me actually, I'm going to scroll in here. I'm going to move up here. So there'll be an arrow that goes up here. So to solve, the formula is AX equals B. Okay, this is matrix A, this is matrix B. We don't know what X is. That's what we're looking for, because that is the answer to our set of equations. That is our XY. So this is a vector, which we will discuss later on, where it is basically, it's storing all of your variables. So XY, XYZ, depending on how many systems there are. If it's a 2 by 2, if it's a 2 equation, 2 unknown, you'll have X and Y. If it's a 3 equation, 3 unknown, you'll have XYZ. Okay, so to solve for X, you'll do X is, and you will take your A matrix and take the inverse. And how you get inverse is you push the X to the -1 button. Okay, that gives you the inverse. Okay, you'll take the A matrix and you will multiply it by B. Okay, and that will give you the answer that you look for, and it will give it as a, depending, again, if it's a 2 by 2, it'll be a 2 by 1. If it's a 3 by 3, it'll be a 3 by 1. But it'll give you the answer in a 1-column vector. So in the example that I did in class, when we used elimination, then we checked using the matrix, it was 8, I believe it was 8, -2, 0 was our answer. That's how they listed it. And that's how you will need to, and I would actually prefer if you put it in coordinate plane form, so 8, -2, 0. But I won't count off. You could do it either way, and that will work. Okay, so those are a couple things I just wanted to go over. So the first was, again, it was classification of systems. Okay, so consistent or inconsistent, and with inconsistent, there's independent and dependent. And that will tell you what kind of solutions there are, whether it's one, infinite, or not, or no solution. Then I want to really quickly go over how you set up the matrices and you solve. There is a sheet that I posted in Google Classroom as well, which is for solving systems of 3 equations by elimination. You can look through that and browse through that. Again, there's graphing, there's substitution, there's elimination. And then for inequalities, if you have to graph inequalities, please make sure you are wary of the inequality. If it's less than or greater than, the line is dashed or dotted. If it's less than or equal to or greater than or equal to, it is a solid line. And then make sure that if it's greater than or greater than or greater than or greater than or equal to, you shade above the line. And if it's less than or equal to, you shade below the line. I highly encourage you bring colors so that you can differentiate the lines with color. And that would help me as well. I hope you found this video helpful. Again, please post comments in the comment section or ask questions in Google Classroom or email me. All right. Thank you for your time and good luck.